So there are three different kinds of popular machine learning techniques, and these are supervised learning, unsupervised learning, and reinforcement learning. And then there is another field which is known as deep learning, and you can attach the deep word to almost anything. So it becomes deep supervised learning, deep unsupervised learning, and deep reinforcement learning. So in this particular part, we'll discuss what supervised and unsupervised learning are. So let's assume we have this image, right? And you can see in this image, there's an algorithm. We do not care at the moment what this algorithm is, but I developed this algorithm like back in 2015 to detect road in these kind of colony kind of environments, right? And this was done using one of the algorithms known as kernel linear regression, right? So that algorithm was actually used to train the system to be able to detect the road in images. So let's suppose our goal is actually to detect this road, right? So how does supervised learning work, right? We do not care about the algorithm at the moment. We are just discussing the field at large. So in supervised learning, what you have to do, a person has to label these images, right? So we can see the boundary. Let's suppose the boundary of the road is like this. Let's ignore this portion for now. And we just assume that this is our actual road, right? Somehow I'm just drawing it roughly, not exactly. There might be some errors in drawing. But let's suppose that this is the ground truth boundary that separates road and non-road regions. So as we can see that this blue boundary actually denotes the ground truth, or the ground truth means the actual pixels that a human being thinks belong to road region, and anything else outside this boundary, that is anything over here, is non-road, right? So in supervised machine learning, a human being has actually has to supply many such images with labeled boundaries. So we have to supply let's suppose millions of such images where we actually draw the boundary as to say to the algorithm as to what we believe the road is and what we believe is a non-road region. So we have a demarcation through this blue boundary, right? So anything inside this boundary is road region. So every pixel, there may be hundreds of thousands of pixels. So all those pixels will have a label road. And all the pixels outside will have a label non-road. And each of these images will have hundreds of thousands of such pixels, and will perhaps pass thousands or perhaps millions of such images to a supervised learning algorithm. It can be even deep supervised learning algorithm, right? So we'll pass such images, and through these labels that we supply to the algorithm, through these labels, the algorithm will be learning how to assign labels to some new image. So let's suppose you get a new image, you supply a new image, and in that image you have to label every pixel. So you will use that image and you will pass it to the same algorithm, and that algorithm will again assign labels saying non-road or road. So this is what in a nutshell supervised learning is. In supervised learning, you have to supply the data. The data actually denotes the samples. So for example, here the samples are pixels, right? For each pixel in this image, we have a label road, right? And for each of these pixels, we have the label non-road, right? So we have some sort of data where we have some pixels and their corresponding labels. And we pass this data to a learning algorithm, and that learning algorithm then learns to label, to assign labels to pixels in perhaps new images that roughly belong to the similar kinds of environments on which we trained the algorithm. In unsupervised machine learning, on the other hand, we do not have these labels. So we just have an image, we do not have any such boundary. This boundary is no more over there. In unsupervised learning, we just supply this image, and now it is a task of the learning algorithm, without using these labels, to assign the pixel to every label in this image. So for example, the task of this unsupervised machine learning algorithm can be to identify how many different objects are actually there in this image. So here we can see that there is a car, then there's a person, there's a road, and then there's a generalized background environment. And we do not supply labels for these pixels. The goal of unsupervised machine learning is actually to learn the number of labels that can be assigned in this particular image, and then to actually assign those or all those labels to each of the pixels in this image, right? So in supervised machine learning, we have pixels and their labels. In unsupervised machine learning, we'll just have pixels, and the machine will automatically identify what the labels should be, and then each of these pixels will be assigned a particular label. So in supervised machine learning, we have a data, or you can say a data set, which will denote by D, which is a set of some points xi and yi, where xi are known as the feature vector. In our case, in the images, these were pixels. So in case of pixels, this will represent the RGB, the red, the green, and the blue channel value. So here the xi's are a three-dimensional integer vectors, or we can normalize them. So this can be an n-dimensional or three-dimensional real vector. The yi's were the labels. In the previous example, we considered the labels were road or non-road. In unsupervised machine learning, on the other hand, we only have the data, we do not have the labels. So there we have a data set D with some points xi's, where again each of those xi's are real vectors. They can be n-dimensional real vectors. But we do not have the labels. And now in unsupervised machine learning, there are two things. One, the machine should be able to identify the number of labels or the labels automatically. Number of labels or the kinds of labels. Sorry for the mistake. And second, each of the input variable or the input feature vector, the xi's, the machine should be able to assign the labels. She should map each of those xi's to those labels that the machine has identified, or the algorithm, the learning algorithm has identified. So this is how supervised machine learning differs from unsupervised machine learning. In supervised machine learning, the data set is some feature vector plus some labels. In unsupervised machine learning, the data set is only the feature vectors, and it's the task of the machine to learn the labels and then to assign the labels. So here in supervised learning, the goal is actually to learn a functional mapping f. We'll denote it by some function. So there is some function that takes in these xi's and produces yi's. So yi are produced by this functional mapping plus perhaps some small error, right? And these errors are, we can assume that they are random error, right? So each of these epsilon I are independent random error. It means that if on the example xi there's an error epsilon I, and an example xj there's an error epsilon j, then epsilon j is independent of epsilon I, or we can say in terms of probabilities, the probability of epsilon I does not depend, or the probability of epsilon j does not depend on epsilon I, right? So this is the goal in supervised machine learning. Given the data, we learn a function that learns how this data is generated. It learns how to map each of these xi's to yi's. And then when any new data point x hat appears, we can pass it to the function and we can get its corresponding label y hat. So that's all about the introduction of supervised and unsupervised learning. Now we'll introduce you what reinforcement learning is. So now we'll introduce you reinforcement learning, and we'll very briefly discuss how it differs from traditional supervised and unsupervised machine learning algorithms. So reinforcement learning is used to solve some task. In a nutshell, or crudely speaking, it is used to solve some real-world robotics and control task. And in supervised machine learning, we have to provide the data with the label, and in supervised learning, we just have the data and the machine's task is to figure out the labels and to assign the labels. In reinforcement learning, the learning happens via natural interaction with the environment. So in reinforcement learning setting, there is an agent. And there's an environment through which the agent interacts. For example, this agent can be a robotic system, or this agent can be any intelligent program, or you can say this agent can be an autonomous driving vehicle. And there's an environment of an agent. An agent has several actions, right? At any particular time step, which you can denote by t, agent is in some state, which you can denote by s of t. For example, to crudely understand what s of t represents, for example, you're controlling, you're having an autonomous vehicle, and the vehicle is at an intersection. An intersection, it has to take a decision whether the vehicle should move forward or should just stay still, right? So there would be some state of the autonomous driving vehicle. For example, the state can be the configuration of the environment and the configuration of other obstacles in the environment and their velocities, right? So this entire information vector constitutes the state of an agent. An agent has certain number of actions, which we denote by all possible actions that an agent can take at a particular time step t as at. So at any given time step, agent selects one of the actions from this set of actions. And this action taken in state st, when the robot interacts with the environment, it changes the state of the agent. So by taking an action, the agent will do something in the environment and that will change its state. For example, if the vehicle is at an intersection and it decides to move, so that movement will create a different state because the configuration of the environment will change. So this action results in a different state, which will denote by s of t plus 1. And the environment provides a reward signal, which we denote by r t plus 1. And this reward tells this agent how good this action is, right? So through this interaction where there's an agent is in some state, it takes some actions, that action results in some reward. And that reward signal tells the agent how good the selection of particular action A of t was in the particular state st, right? And through this sequential, through this process of taking an action in the subsequent states, the agent receives these reward signals, and through these reward signals, for all the states, it learns what actions to select, what actions will lead to a greater reward or a greater return. So this is roughly or crudely speaking what reinforcement learning is. So as you can see from the description itself, reinforcement learning is more used to solve some real world control task or real world robotic task. So that's it for our brief discussion about reinforcement learning. And now in the next part, we'll cover some of the notations that we are going to use in this course.